This is Physics for Grade 12, produced by Tigray Education Bureau, transmitted by Dimtsi Weyane Tigray National and FM radio satellites and social media, and also FM Maqala 104.4.
This is Physics lesson for grade 12. Now we will discuss on Unit 5. Lesson topic: steady electric current and circuit properties. In the previous lesson, Unit 4, we discussed on electrostatic, which is electric charge at rest. In this unit, we will discuss on electric charges in motion. Dear students, in today's lesson, we will try to discuss the relationship between conductivity, resistivity, resistance, drift velocity, and current density are related. Basic principles. An electric current is a rate of flow of charges. If you compare an electric current with water, a small current is like a trickle passing through a pipe, and a really large current is like a river in a flood. Dear students, you learned that the current is a fundamental quantity and its SI unit is ampere. Materials are classified as conductors, insulators, and semiconductors according to their conductivity. This classification is purely based on the available number of free electrons within the materials apart from the bounded orbital electrons. So, the word conductivity is used to describe a material's ability to transport electricity. During solid formation, the outermost energy levels of the atoms overlap with each other to form a band of energy. An energy consists of closely spaced energy levels, which are considered to be continuous. The outermost electrons of an atom are called valence electrons, and the band of energy occupied by the valence electrons is known as valence band. This valence band may be partially filled or completely filled, but cannot be empty. The next higher permitted band of energy is called the conduction band. It is located above the valence band. The electrical conductivity of solids depends on the number of electrons present in the conduction band of their atom. The conduction band may be empty or partially filled, can never be completely filled. When the electrons reach the conduction band from the valence band, they can freely move, so they are called as free electrons or conduction electrons. Thus, free electrons are responsible for flow of electric current through the solid. Different materials have different numbers of conduction electrons. Dear students, define the following terms. Question: what is conductivity, resistivity, and resistance? You have 40 seconds to answer for the question. I hope you have answered the question. If not, conductivity is a way of measuring a material's ability to allow an electric current to flow. Its units are Siemens per meter. Its unit is Siemens per meter. The inverse of conductivity is resistivity. Resistivity is a measure of how much a material resists the flow of electric current. Its unit is ohm meter. Resistance is a property of a material that controls the amount of current that flows through it. Its unit is ohm. Let me ask you a question. At a given temperature, what are the factors that affect the resistance of a wire? You have 30 seconds to answer it. If you got the answer, well done. If not, the answer is 1. Its length in meters. The resistance is proportional to length. So, the length doubles, so does the resistance. 2. Its area of cross-section in meter square. The resistance is inversely proportional to area. So, a wire with twice the cross-sectional area will have only half the resistance. 3. The resistivity, that is, from which the material is made of. A material with higher resistivity will have a higher resistance. Dear students, what happens to the resistance of a wire when the temperature of the wire rises? You have 30 seconds to answer it. Well, I hope you have answered correctly. The answer is the resistance of the wire increases. Dear students, so far we discussed the motion of electric charges. This also relates with drift velocity and current density. Drift velocity is the average velocity that an electron reaches when an electric field is applied across a conductor. And current density is a vector quantity, which means it has both magnitude and direction. Its magnitude is the current per cross-sectional area. The current density, which assumed that the current is proportional to the electric field. Let me ask you a question. Question: what considerations are taken when we design electrical and electric system? You have 30 seconds to answer it. If you got the answer, well done. If not, circuit performance depends strongly upon the designed current level, and the current density then is determined by the dimensions of conducting elements. Dear students, how does a source of electromotive force produce a potential difference? When a battery is connected across a piece of copper, it pushes the free electrons so that they flow through the metal and produce an electric current. The electrons start to flow instantaneously because the free electrons are already spread through the wire. Electrical circuits transfer energy from batteries to the other components. The chemicals in the battery are a store of energy. When the circuit is closed, the energy from the battery pushes the electrons around the circuit and transfers the energy to the components, which can then work. The energy or push that the battery gives to the circuit is called the voltage or electromotive force of the battery. It is measured in volts, which have the symbol V. The higher the voltage, the greater the amount of energy that can be transferred. Voltage is a measure of the difference in electrical energy between two parts of a circuit. Voltage is sometimes called potential difference. Potential difference measures the difference in the amount of energy the circuit is carrying either sides of the component. This voltage drop across the component tells us how much energy the component is transferring. Potential difference is defined as energy per unit charge. The unit of potential difference is volt. Using the definition, we can define the volt as joules per coulomb. 1 volt is equals to 1 joule per 1 coulomb. 1 joule is the energy exerted by a force of 1 Newton acting to move an object through a distance of 1 meter. Students, what is the relationship between electromotive force, terminal potential, and internal resistance? Suppose you have a short circuit with a battery. This means that you join its two terminals by a circuit that effectively has no resistance. A short piece of very thick copper wire, for instance, the battery has electromotive force V, but the circuit apparently has no load resistor, which is capital R. What happens then? Does the circuit increase without limit? Students, the answer is no, because the battery has an internal resistance. The biggest current it can deliver by a 1.5 volt torch battery is 1.5 ampere. Dear students, in next class we will discuss on combining resistors and Kirchhoff's rule. Until then, do the review questions in your exercise book on page 212 up to 213. Till then, bye-bye.